session is the second session on chi-square test. In this session, we deal with test of independence of attributes. Attributes are nothing but qualities or characteristics possessed by a population. When you want to test whether two or more attributes or qualities uh, present in a population is dependent or independent, then you can use the chi-square test of independence of attributes. Moving on, the chi-square test of independence is used to determine if there is a significant relationship or association between two nominal variables. It's also known as categorical variables or qualitative variables. The frequency of each category for one nominal variable is compared across the categories of the second nominal variable. Say for example, if you want to test whether beauty is related with intelligence or not, or whether the two variables beauty and intelligence is associated or not. So what is being done here is we are going to check whether or the variables will be categorized in such a way that one variable is compared across the categories of the second nominal variable. There will be people who are intelligent or not intelligent. We'll be checking whether how many people who are beautiful is intelligent and how many are not intelligent. So that is a way in testing the independence of attribute. The data can be displayed in a contingency table where each row represents a category for one variable and each column represents a category for other variable. So in testing the independence of attributes in a chi-square test, for testing that, the data will be presented to you in the form of a contingency table. If you are dealing with two attributes, then it will be a 2 into 2 contingency table. For example, say a researcher wants to examine the relationship between gender and empathy. He classifies gender as male and female and empathy as high and low. So if you want to check, if the researcher want to check whether empathy is related with gender, whether male are more empathetic or female are more empathetic, then he can use the chi-square test of independence of attribute. So what will be the hypothesis that he will set? He will set that the two variables are not related, are not associated, or these two variables are independent. They are not dependent on each other. That is the way he will formulate the hypothesis. Then, when there is only two divisions of each attribute that I have already mentioned, then we have a 2 into 2 contingency table. If there are three divisions of each attribute, then there will be a 3 into 3 contingency table. Usually in chi-square, either you will be getting a 2 into 2 contingency table or 3 into 3 contingency table. If it deals with more variables, then other tests like ANOVA will be useful to apply. Then, what are the steps involved in testing the independence of attributes? Of course, in any statistical testing, hypothesis testing, the first and foremost step is to set up a null hypothesis. So, here also the first step is to set up a null hypothesis that the attributes are independent. You can either set it as the attributes are independent, or you can set it as these are not associated. So in the case of gender and empathy, you can either say that the gender and empathy are independent variables, or you can say that gender is not associated with empathy, or empathy is not associated with gender. Then the next step was to compute the test statistic. So like in goodness of fit, the test statistic can be calculated with the same formula, that is sigma O minus E square by E. Unlike in parametric test, you need not study lot of formulas. In chi-square test, there is only one formula, that is O minus E square by E. The observed frequency will be given in your contingency table, but you will have to find out the expected frequency. The expected frequency can be calculated by the following formula, that is row total into column total by grand total. Okay, you can find out the expected observation or expected frequency of each cell in the contingency table by multiplying the row total into column total, which should be divided by the grand total. Clear? Then the third step is to find the degrees of freedom. In goodness of it, we have calculated the degrees of freedom as n minus r minus 1. And in testing the independence of attributes, the degrees of freedom is r minus 1 into c minus 1. R is a number of rows and c is a number of columns. So in all 2 into 2 contingency tables, the degrees of freedom will be 1. And if the table is a 3 into 3 table, the degrees of freedom will be 4. So the next step was to obtain the table value with for the degrees of freedom and decide level of significance. Okay. The table value in the chi-square distribution at 5% level of significance, you can find the table value. Here, you have to note one thing. In this question, the question doesn't tell you anything about the level of significance. If the question is silent about the level of significance, you should always take 5% level of significance. If more accuracy is required, it will be mentioned in the question to test the hypothesis at 1% level of significance. In all other cases, and in cases where the question is silent about the level of significance at which you have to test the hypothesis, take it as 5% level of significance. And then if the calculated value is less than the table value, you can accept the null hypothesis. And if you are getting a calculated value much more than the table value, then you can reject the null hypothesis. So these are the steps involved in testing the independence of attribute. I will repeat again. That is, first is you have to set up a null hypothesis. Then you have to calculate the test statistic, and then you have to find out the expected frequencies, expected cell frequencies for each cell in the contingency table. Then calculate the degrees of freedom and obtain the table value and compare it. So we'll move on to an example. So from the following data, use chi-square test and conclude whether inoculation is effective in preventing tuberculosis. This is the question. Inoculation is nothing but preventive vaccination, and whether this vaccination is helpful to prevent tuberculosis. This is the two. So the two attributes in this is inoculation and attack of tuberculosis. Okay, attack and inoculation are the two variables. So the data is given. Among the inoculated people, that were people who were got vaccinated, 31 got tuberculosis and 469 didn't get it. And among the persons who are not inoculated, 185 were attacked with TB and 1315 did not get tuberculosis. So in such a question, the first thing that you have to do is you have to set up a null hypothesis. What should be a null hypothesis? That is, the two attributes inoculation and attack of tuberculosis are independent, or inoculation does not prevent tuberculosis. It's not associated. So the two attributes, attack and inoculation, are independent. In all the ways you can write the hypothesis. Either you can write that they are independent, or you can write that there is no association between inoculation and tuberculosis. Then next is you have to, in order to calculate the test statistic, you need the expected frequency. For finding the expected frequency, you have to find out the row total and column total and grand total. Row total, column total and grand total. And with this formula, you can find out row total into column total by grand total. You can find the expected frequency of each cell in the contingency table. See, I have written the observed frequencies in a vertical manner: 31, 469, 185 and 1315. And The expected frequencies as calculated with the formula, it is 54, 446, 162 and 1338. Then O minus E square, all the O minus E square is 529. Then O minus E square by E, you will get this value. And chi-square is the sum of all these O minus E square by E, sigma O minus E square by E. And you will get the chi-square value as 14.66. Once you get the test statistic, the next step is to find the degrees of freedom. The degrees of freedom here is R into R minus 1 into C minus 1, and that is 1. And the next step is to find the table value. The table value for 1 degrees of freedom at 5% level of significance is 3.841 as per the table. Okay, now compare the calculated value of 14.66 and the table value of 3.841. As the calculated value is higher than the table value, you have to reject the null hypothesis. When will you accept the null hypothesis? You can accept a null hypothesis only if the calculated value is less than the table value. Here, as the calculated value is more than the table value, the null hypothesis is rejected. Okay. Do more problems related with independence of attribute so that you will familiarize with finding expected frequencies and finding the table values. Okay. If you have any doubts, please do clarify.